Hey class, today I'm going to talk about the course objectives, prerequisites, and roadmap for the first ever full-length course on this channel. If you haven't done so already, you should check out my previous video about why you should care about programming languages. This video will be more logistical, but I thought it was important to include nonetheless. The two essential questions for this course are, what is a programming language, and why care about programming languages? These two questions will guide our exploration of this topic. For our specific course objectives, we aim to understand concepts across programming languages, understand strengths, weaknesses, and use cases of different programming language paradigms, develop an appreciation for programming languages, and lastly, learn the basic principles for creating a simple programming language. So, what even is a programming language? My first answer is that a programming language is Java, C++, Haskell, Racket, Prolog, etc. That is to say, a programming language is a tangible thing that we code with. The first module will explore programming language paradigms. We will take a breadth-first look at object-oriented programming, functional programming, and logic programming, and make a stop by domain-specific languages and esoteric languages as well. But why do we consider these things to be programming languages? Our second answer to what is a programming language is that a programming language contains certain features that we expect it to. In this module, we will review some old concepts such as variables, conditionals, loops, and functions, and also explore new ideas like type rules, operator precedence, strict versus lazy evaluation, and scope. You might have heard about higher-level programming languages and lower-level programming languages. This concept connects to our next answer to the question, which is, a programming language compiles to another programming language. In this module, we will learn how to compile one programming language to another, utilizing concepts such as syntax and semantics, abstract syntax trees, evaluation, and parsing. But maybe you want to get more theoretical. Our last answer to the question, what is a programming language, is that a programming language is an instantiation of lambda calculus. That's right, the last module is entirely dedicated to lambda calculus, a theoretical framework for understanding programming languages, particularly functional programming languages. Lastly, we will have an entire module called Why Care, where we discuss the applications and impacts of programming languages, as well as considerations for choosing and using programming languages. There will also be an optional module where we implement a simple arithmetic language using Haskell. To summarize our lesson plan, first, we learn about programming language paradigms. Then, we will learn about features of programming languages. Next, we will learn about compilation. After that, we will learn about lambda calculus. Lastly, we will learn about why we should care about programming languages. And as a bonus, there is an optional tutorial for implementing a simple programming language in Haskell. Here are some important things to know about this course. First of all, think of this course as a breadth-first introduction to programming languages. We're not going to get too in-depth into most topics, but I'm hoping that this will give you a really solid foundation for further study in this area. For the prerequisites, this course expects that you have prior programming experience, so for example, familiarity with concepts like recursion, variables, types, and control flow, and also knowledge of basic data structures like arrays and trees. It also helps to have some familiarity with context-free grammars, but we'll also review that concept when it comes up. That wraps up our course intro. Thank you so much for watching, and I hope you'll join me next time for our introduction to programming languages paradigms.